Now let's complete the test. So here is the ANOVA table, how it should be constructed. So let's start with degrees of freedom. So degrees of freedom for regression for our example, there is only one x, so that is 1. Total degrees of freedom is n minus 1. So we have the sample size here, so n minus 1. So residual degrees of freedom or error degrees of freedom would be that minus that. Okay. Now sums of squares are, so we have them assembled here. The first one is SSR. The second one is SSE, which is that. And SST will be the sum of these two, or we can get it from here. Okay. Now mean square is take sum of squares, you divide by the degrees of freedom, the same here. SSE divided by degrees of freedom. Okay, let's have the same number of decimal places. Then mean square regression divided by mean square error. So that's our F. Okay. And the p-value is f dot this dot rt. Okay. So first is the f value, and then we have 2 degrees of freedom. The numerator degrees of freedom first. So numerator degrees of freedom is that. Okay, numerator was MSR, so MSR's degrees of freedom is your numerator degrees of freedom. And the denominator is MSE, so the degrees of freedom for MSE is that. Okay, now that will give us the p-value. Okay, we'll talk more about p-value in just a second. So now we have everything we need to do the test. So first thing we have to do for the test of significance is to set up the hypothesis. We have to have a null hypothesis and an alternative hypothesis. So the null hypothesis is that it is not significant. So it will be beta sub 1 equal to 0. And the alternative is beta sub 1 not equal to 0. So not equal to, you can get the not equal to symbol from here. Insert symbol, and you can select that. Okay, well, let's adjust the font size. All right. So now we have to set up a level of significance. It's called alpha. And typically alpha is set at 5%. Okay. Now we can come to a conclusion about the hypothesis based on a comparison between p-value and alpha. The p-value here states what is the probability that you will commit an error if you reject the null hypothesis. Okay, so you will commit an error if the null hypothesis is true, but you go ahead and reject it, and you go with the alternative. So that is called type 1 error. A true null hypothesis and you reject it. Okay, and this p-value gives you the probability of that. P-value is the probability of rejecting a true null hypothesis. So if this probability is way too high, then that's too risky. You don't want to reject the null hypothesis because the probability that it is true is quite high. So what is quite high? What is that threshold limit? That is what is given by alpha. Alpha is the significance level, that is the ceiling for p-value, okay, up to which you will feel free to reject because the risk is quite small. But once you hit that ceiling, okay, and if you exceed that ceiling, then it is too high a risk for you to reject the null hypothesis. So in this case, this is let's let's express that as a percentage. So now you see it is 3.94%. It is within the ceiling, so we can feel free to reject the null hypothesis. So reject HO because p-value is less than alpha. Now reject HO means what? When you reject the null hypothesis, you're rejecting that the slope is 0. So we know that if the slope is 0, then the x is not significant. X has no influence over y. So when you say I'm rejecting HO, which means the slope is not 0, so that means the regression is significant. And the probability that we are committing type 1 error is 3.94%. So this is how we will interpret that. We have sufficient evidence to conclude the regression between sales as the dependent variable and the local payroll as the independent variable is significant. The probability this conclusion is wrong, which is really type 1 error, so what the probability that we will be committing type 1 error is 3.9%.